Let us see the next sequential circuit using the flip-flop circuit we have seen. It's a counter. So how to design a counter using VHDL? It's one of the important digital circuit. So without counter we cannot able to generate a pattern of clocks. We can able to decode the specific pattern and we can count the clock as well. We can generate new clocks also. So counter is one of the important circuit. So this is a simple 4-bit counter and I have illustrated how the counter works. So counter is nothing but which is used to count the clock. So with respect to clock and reset, so we initially give the data at every rising edge of the clock, rising or falling edge. So here I have given rising edge, 1 bit will be counted. So I given as a +1 acts as accumulator. So at every time the clock triggers at rising edge, so 1 count will be added up. That's the basic logic of counter. So I'll show you how to make a counter design. So I took a empty RTL editor. I just copy the previous template, like clock divider code I will take. So I make it as counter entity. Since the entities and all same, I just copied that. And clock clear or 1 bit, so refer this, but the data will be 4 bit. So now declare a new input called data. So input standard underscore logic underscore vector of 3 down to 0, and our as per the diagram the output will be Q or Y, whatever it may be, that will be 4 bit. So now make the Q equal to standard logic underscore vector of 3 down to 0. So since I am going to add the same kind of operation, so I need a temporary variable that also should be in 4 bit. So standard logic underscore vector of 3 down to 0. So now everything is clear, and I rename the label as counter block so that it match with my work. Counter block, and temp equal to initially 000, from which count also you can customized count also you can make. So temp equal to temp plus 1, that's all. So one more thing you need to note at this point, like we are making the accumulation operation. So here we are newly adding the arithmetic operation, so we have to include another library called uisng dot standard underscore logic underscore unsigned dot all, which is opted for arithmetic operations. So we have a set of around 10 to 11 library files that will be mentioned in the document, and depends on the requirement only we will start adding up the libraries. If those libraries are not required, means we can ignore it. Okay, so I added the arithmetic operation, so I added this library, and the purpose of each and every library will be mentioned in the document. So counter, I'll run the counter code. So compile, compilation, simulate. I hope you watching the previous videos you become familiar about how to utilize the model sim window, clock by applying clock, clear by applying clear. If it is not familiar, please go and see the previous videos and come back here, so that will be very easier for you to understand the codes. So data initially I given as 000. So slowly run, make the clear to release. So this clear is nothing but the completely the hardware operation, like how the switch, that is the reset switch, works. So now you got the counter output. So at the rising edge of clock, so 1 count will be triggered. And the beauty of digital design is by designing one circuit you can get another outputs Like a simple counter acts as a clock divider also on the other hand. So you can see the clock is being divided by 2 in 0th pulse, that is the LSB, and divided by 4 in first, divided by 8, divided by 16. So similar way you can utilize a simple clock divider also used as a clock generator. So that's the simple clock divider counter circuit. Simple 4-bit counter.